Hello and welcome. In this video, I will demonstrate how to configure Eigrp dynamic routing protocol in a network topology. On the screen, I've built a topology with 4 routers and 2 layer 2 switches. If you wish to follow this lab, now is a good time to pause the video and make a note of the IP addressing scheme that you see at the top of the topology here. So far, I've configured IP addresses on all of the interfaces on the routers and have verified that each router can actually send pings to its neighbor. Now, the goal is to have PC0 in network 192.168.10.0, that's this PC here in this network, successfully communicate with PC1 in the 192.168.20/24 network. To achieve this, all routers must know about all other routes in the topology and to have redundant or backup routes to each network in case the primary route fails. I will show you several different ways in this lab how to configure and advertise networks in Eigrp. Now let's start with the configuration on router 1. Now I have router 1 up and I'm in the global configuration mode. The network that I have to advertise on this router is 10.1.1.0 network. That's the network between router 1 and router 2. And I also have to advertise the 10.1.1.8 network. Now all the IP addressing scheme that I've built around between these routers, they're all /30 network. Now the first method that I'll look at is the traditional way of advertising a network in Eigrp. In this network, I'll use an AS number of 10 for Eigrp, and this network number or this ASN number of 10 will have to be common on all the routers in the topology. It cannot be different on any of the routers. They must be in the same ASN number. Now the command to start the Eigrp process on a router is router Eigrp, and then you put the number 10. Now the traditional way of advertising a network in Eigrp would be the network. So the command router Eigrp 10 starts the Eigrp routing process on the router. The next step is to advertise the network that the interfaces belong to. Now the first network I'll advertise is 10.1.1.0. That is the network between router 1 and router 2. The traditional way of doing this will be network 10.1.1.0, and now I'll have to use a wildcard mask, which is the inverse of the subnet mask. So because it's a /30 network, the wildcard mask will be 0.0.0.3. Next network that I'll want to advertise is out of interface GI0/0. So this interface is in or connected to the network 10.1.1.8, and it's a /30 as well. So 0.0.0.3 and enter. So now it's advertising these two networks. Now if I go over to have a look at the IP protocols, on this router you can see that I have the routing protocol that is currently enabled is Eigrp, and the AS number is 10, and I'm advertising the networks 10.1.1.0, and it's a /30, and 10.1.1.8, and that's also a /30. So the next router that I'll be configuring, so on router 2 I start by entering the router Eigrp 10 to start the Eigrp routing process on the router. And the next thing is to advertise the network way of advertising the network, but this time with a subnet mask instead of a wildcard mask. Now you can use a subnet mask. What Eigrp will do is to flip the subnet mask and correct it to the correct wildcard mask. So to do that, we'll advertise the network, and that is a 10.1.1.0 because this is the network between router 2 and router 1. And now I'm going to go ahead and use a subnet mask, and it's a /30, so the subnet mask will be 255.255.255.252, like that. Now you can see that as soon as I enter that command, it formed an adjacency, and it's telling you that it's forming an adjacency with 10.1.1.1 out of this interface gigabit 01. So the next network that I want to advertise is the network between router 2 and router 3, and that's a 10.1.1. So it's the same command I'm repeating, excepting that I'm using network 10.1.1.4. I cannot use 0 because 0 is between router 2 and router 1. So now I'm advertising the network between router 2 and router 3, and this is a 10.1.1.4 network. And I'm using the subnet mask again instead of the wildcard mask. Looking at the running configuration on router 2, and these are the networks that I'm advertising. Now you can see here the network is 10.1.1.0, and look at the wildcard mask here. So you remember I'd actually use the subnet mask of 255.255.255.252, which is the correct subnet mask for this /30 network. But in Eigrp, when I advertise the network with a subnet mask, it automatically flips it and corrects it to put in the wildcard mask. So far what I've done is enable the Eigrp routing process between router 1 and router 2, and I've advertised the network between these two routers 1 and 2, and I can see that the neighborship has been formed. I've also advertised the 10.1.1.8 network on router 1 and the 10.1.1.4 network on router 2. So next I have to move on to router 4 and router 3 to configure the Eigrp so that all of the routers can form a neighborship between their neighbors. Now the ultimate goal of this is to have PC0 being able to communicate with PC1. So currently these PCs are not able to communicate with each other, and if I go ahead and do a ping from PC0 to PC1, and PC1 IP address is 192.168.20.10, I should not be able to reach that PC. I'm getting a reply from my router IP address to say that the destination is unreachable. And of course, if I look at router 4 routing table, I will see that there's no network available to the network of 192.168.20.0. It's missing from here. So once we have Eigrp configured, all of the routers should be able to communicate with each other, and my PC in this network of 192.168.10.0 should be able to communicate with the PC in 192.168.20.0. The next step is to configure Eigrp routing process on router 3 and on router 4. I will use a different method to advertise the networks on these two routers. Now both routers have 3 networks to advertise. So instead of using separate network commands to advertise each network, I can use a single command to advertise all the networks. So on router 4, I've run this command show IP Eigrp interfaces, and I currently have no interface on this router taking part in the Eigrp routing process. The networks connected to this router, here I have gigabit 00, gigabit 02, and gigabit 01, all in different networks of course. And on the routing table I can see these are the networks that I want to advertise. So 10.1.1.8/30, then 10.1.1.12, another /30, and a 192.168.10, which is connected on gigabit 01. similar to what I have on my topology here. So the first command is to start the routing process. So router Eigrp 10, and that command that will advertise all of the networks at the same time will be network with all zeros. So 0.0.0.0. That's the command, and that's the only command I'll have to enter. And what it will do is place all the interfaces on this router in the Eigrp routing process. Now, if I repeat the command show IP Eigrp interfaces, now I see that all of the interfaces is now part of the Eigrp routing process. I'm going to go ahead and run the same command on router 3. So the command again is network 0.0.0.0, and straight away it forms a new adjacency, and this router 3 should have an adjacency with two routers, router 4 and router 2. So if I run the command again on this similar command, show IP Eigrp interfaces, I can see all my interfaces running Eigrp. That's gigabit 00, 01, and 02. I can show my neighbors. And here I have a neighborship with 10.1.1.13, which is router 4, and 10.1.1.5, which is router 2. Now if I go to my routers and show IP route, now I can see that I have how many networks: the 10.1.1.0, 10.1.1.4, 10.1.1.8, 10.1.1.12, and here's my 192.168.10.0 and 192.168.20.0. So all of the routers should have a similar view of the network. Let's go to a random, maybe router 1, and show the IP route. And here I can see all my networks as well. So I should have four of the 10 networks, and 192.168.10 and 192.168.20 here. If I come to router 4, here again I can see that I have all my networks. Okay, so from PC0 I should now successfully be able to ping the PC1 in the 192.168.20 network. So it's taking a little bit of time because of Eigrp, so it's missed the timed out in the first because the network is doing the Eigrp, and here I can get a reply from the PC on the other end, which is PC1. If I redo the ping command, I should now have 4 replies. So what I've covered so far in this video is to demonstrate how to start the Eigrp routing process on a router, and we were successfully able to advertise networks using various methods in Eigrp. So hope you enjoyed this video, and thanks for watching.